There is a patent sitting in the United States Patent Office archive that has never been manufactured at commercial scale. Patent number 1,895,003, filed in 1929, granted in January 1933, an overshot water wheel with a variable geometry bucket system that its inventor documented as achieving 94% mechanical efficiency from any stream with a minimum 6-inch head drop, 94% efficiency from 6 inches of water drop, from a stream so small you could step across it. The inventor's name was Harold Fessenden Cook. He was an engineer in Bucks County, Pennsylvania. His workshop was 12 miles from the nearest Amish settlement in Montgomery County. He spent 11 years developing and refining his wheel design, running it through 14 prototype iterations on a tributary of the Neshaminy Creek before he filed the patent. He believed he had solved the efficiency problem that had limited small-scale water power adoption for 2 centuries. He had letters of interest from 3 agricultural equipment manufacturers. He had a production agreement drafted with a foundry in Reading, Pennsylvania. In 1932, the Pennsylvania Public Utility Commission introduced a new interconnection requirement for any mechanical power system that could be adapted to electrical generation within a defined radius of existing transmission infrastructure. The requirement did not ban Cook's wheel. It required that any commercial sale be registered with the PUC, and that the buyer demonstrate the device would not displace utility-provided electricity in service areas already covered by grid infrastructure. The foundry in Reading was in a covered service area. Every manufacturer that had expressed interest was in a covered service area. The production agreement died before it was signed. Cook received his patent in January 1933 and spent the next 9 years trying to find a manufacturing partner outside covered service areas. He died in 1941. His patent expired in 1950. His wheel design, which his own testing documented at 94% efficiency, was never manufactured at commercial scale. The Amish did not need Cook's patent. They had been building overshot water wheels since the 1750s. They had never needed a manufacturing partner. They had never operated in a covered service area. And they had never stopped running the wheels that the rural electrification campaign made invisible to every other farmer in Pennsylvania. By night, stay with me, because what I found in Harold Cook's archive at the Bucks County Historical Society, 3 cardboard boxes that have not been opened since his widow donated them in 1944, tells a story about how an efficiency breakthrough gets buried that is more specific and more disturbing than anything I have documented. Let me start with the wheel itself, because you need to understand what Cook built before you can understand why it had to be stopped. A conventional overshot water wheel, the type that powered American industry from the colonial period through the 19th century, works by directing water onto the top. The water fills buckets or paddles on the wheel's rim. Gravity pulls the filled buckets downward. The wheel turns. The empty buckets return to the top and are refilled. Mechanical power is extracted from the central shaft. The efficiency of a well-built conventional overshot wheel runs between 65 and 85%. The rest is lost to splash and turbulence. Every engineer since John Smeaton's foundational experiments in 1759 had concluded that the losses were structural, built into the geometry of the buckets. Cook's insight was that the losses were not structural. They were sequential. The wheel's geometry was fixed. The water's behavior was not. If you could vary the geometry of the bucket opening as the wheel turned, you could eliminate the filling turbulence and the splash loss simultaneously. The result was a wheel that filled its buckets completely at every position and captured energy that conventional designs could not approach. His 14th prototype, on the Neshaminy tributary, was independently tested by an engineer from Lehigh University named Thomas Brackbull in the summer of 1928. Brackbull measured input head, flow rate, and torque. His calculated efficiency across 15 conditions averaged 91.3%. His peak measurement was 94.7%. Brackbull wrote that the variable geometry system represented the most significant advance in water wheel design since Smeaton. He believed its commercial application would materially reduce the energy cost burden of rural farming operations across the northeastern United States. That report sat in Harold Cook's workshop while the production agreement with the Reading foundry died in 1932. Letters of interest from manufacturers went unanswered through 1934 and into 1935, when Cook finally stopped writing them. The story of the variable geometry water wheel remains a forgotten chapter of engineering brilliance, lost in the archives of Bucks County. I need to tell you about the Pennsylvania Public Utility Commission interconnection requirement in more specific terms, because the mechanism is important and because the same mechanism appears in different regulatory clothing. in every story I have told on this channel. The 1932 Puck interconnection requirement was not written by Public Utility Commission staff. It was drafted by the legal department of Philadelphia Electric Company, which served the southeastern Pennsylvania territory. This included Bucks County, Montgomery County, Reading, and the manufacturing corridor, where every potential production partner for Cook's wheel was located. Philadelphia Electric submitted the draft language to the PUC in March 1932. The Puck adopted it in October 1932, with minor modifications. The adoption proceeding took 7 months and generated 43 pages of transcript. Cook did not know the proceeding was happening. He was in his workshop running his 14th prototype. The interconnection requirement was presented publicly as a grid stability measure. Unregulated mechanical systems that could be adapted to electrical generation created unpredictable loads on transmission infrastructure, the utility argued. Coordination was necessary. Regulation was responsible. The requirement was reasonable. What the requirement actually did was create an administrative barrier between a water power device manufacturer and the rural customers. Not a prohibition, a form, a registration, a demonstration requirement. The same form that a gas furnace manufacturer did not have to file. The same form that an electric motor distributor did not have to file. The same form that only existed for the technology that competed directly with what Philadelphia Electric sold by the kilowatt. Cook could not navigate it without legal help he could not afford. The foundry in Reading was not going to invest in production tooling for a product whose sales required regulatory compliance. The agricultural equipment manufacturers were not going to take on regulatory risk for a product in a market they had not previously served. The commercial path closed. The patent sat. The wheel ran on the Neshaminy tributary until Cook died in 1941, and then it stopped. I asked the archivist at the Bucks County Historical Society whether anyone had ever come to look at Cook's boxes before me. She checked the access log. 2 researchers had requested the collection since 1944. One was a graduate student in 1967, who was writing a thesis on small-scale water power that was never published. The other was me. 79 years, 2 researchers, a 94% efficient water wheel that would cost between $40 and $120 to build from modern materials. Sitting in 3 cardboard boxes that nobody had opened since a widow carried them through the front door of a county historical society in 1944. That is what systematic burial looks like. Not fire, not destruction, just the reliable assumption that nobody will look. Now let me tell you what the Amish were building during the same years that Harold Cook was running prototypes on the Nish, and Philadelphia Electric was drafting interconnection language for the Puck. The Amish water wheel tradition in Lancaster County traces directly to the Rhine Valley mill construction practices from the early 18th century. The Rhine Valley millwrights of the 17th century had developed overshot wheel geometries and flume designs of considerable sophistication, refined over 2 centuries of operation in a region where water power was the primary mechanical energy source for both agriculture and industry. The settlers who arrived in Lancaster County between 1710 and 1740 built water wheels because that was how you powered a farm, not because it was traditional, because it worked and because nothing else was available. By 1800, Lancaster County had more operational water power sites per square mile than any comparable region. The mills along the Conestoga Creek, the Paquia, and the Cocalico were not primitive. They were engineered structures representing accumulated knowledge of head management, flume design, wheel geometry, and shaft power distribution refined over a century. When rural electrification arrived in Lancaster County in the late 1920s and 30s, the majority of non-Amish farms disconnected their water wheels. Not because the water wheels had stopped working, because electricity was being offered at rates that made mechanical power seem uncompetitive in the short term, rates that were subsidized by the Rural Electrification Administration, specifically to accelerate grid adoption. The long-term rate structure that would emerge after the promotional period was not discussed. The short-term offer was attractive. Farmers accepted it. The Amish did not accept it. Not because of a theological objection to electricity in the abstract. The Amish relationship with technology is more nuanced than most outsiders understand, but because accepting a utility connection meant accepting a dependency on an external system whose terms could change without the community's consent. That dependency was what the Amish had come to America to avoid. They kept their wheels. A man named Gideon, who farms in Ephrata Township, showed me a wheel his great-grandfather built in 1897. His grandfather rebuilt it in 1954, after a flood damaged the original flume. The rebuilt wheel has been running without interruption since 1954. 70 years. The wheel itself is wooden, white oak for the rim and spokes, with cast iron hardware on the shaft and bucket frames. The buckets are galvanized steel, replaced by Gideon's father in 1981, when the originals developed rust holes. That replacement, new bucket sheets cut and riveted in the farm workshop over 2 weekends, is the only substantive maintenance the wheel has required in 70 years. The wheel drives a shaft that runs into the barn through a sealed bearing in the wall. Inside the barn, the shaft powers a line shaft system through leather flat belts, the same distribution mechanism that Isaac uses on his mill run. From the line shaft, individual machines are engaged and disengaged by sliding belt tensioners, a simple clutch mechanism that has not changed since the 19th century. Grain grinding, feed mixing, hay equipment, a wood lathe for farm carpentry, a water pump. All of it from one wheel, one stream. Zero electricity. I asked Gideon what he would do if the stream went dry. He looked at me the way the Amish men always look at me when I ask a question whose answer seems obvious to them. He said the stream had not gone dry in 127 years. He said his grandfather had put a gauge rod in the stream in 1922, and they had recorded the level every week since then. The lowest it had ever recorded was during the drought of 1999, when the flow dropped to about 40% of normal for 6 weeks. The wheel ran at reduced capacity but did not stop. He showed me the gauge records in a ledger maintained continuously for 102 years. That ledger is the engineering document that Harold Cook never got to write. Continuous performance data across a full century of operation. No gaps, no failures, no fuel costs, no utility bills. Just a pencil mark in a book every week for 102 years, showing that the stream was there and the wheel was turning. Now, the build. Because I told you this system costs between $40 and $120, and I am going to show you exactly where that number comes from. You do not need a stream with 6 feet of head drop to build a useful water power system at the household scale. You need moving water and any elevation difference. The minimum practical head for a simple overshot wheel is 18 inches. A stream that drops 18 inches over any run length, even a very gentle slope across a long distance, can drive an overshot wheel. The simplest functional overshot wheel for household use is a 4-foot diameter wheel with a 12-inch face width, built from 2-inch dimensional lumber for the rim segments and 1x6 boards for the bucket faces. Standard threaded rod and hardware store fittings are used for the shaft and hub assembly. The wheel mounts on a treated timber frame set in the stream or on the bank. The flume directs water onto the top of the wheel from a simple wooden channel, lined with pond liner material, to prevent leakage. Material cost for the wheel, frame, and flume on a modest build runs between $45 and $80. A cast iron shaft bearing, which dramatically improves longevity and reduces maintenance, adds another $20 to $40. The complete installation runs between $65 and $120. At 18 inches of head and 300 gallons per minute of flow, it produces approximately 1/4 horsepower of continuous shaft power. That is enough to run a water pump, lifting water 30 feet at 15 gallons per minute, continuously, without electricity. For a homestead with a garden or livestock, that output eliminates the electric pump that runs every time the pressure tank calls, eliminated permanently. From a wheel that costs $80 and has no fuel cost and no maintenance schedule. Scale the wheel to 6 feet in diameter with a 24-inch face, and you are producing approximately 3/4 of a horsepower, enough to grind grain, pump water at higher volume, run a small lathe, or charge a battery bank through a small alternator. At 10 feet of head and 600 gallons per minute, a 6-foot wheel produces between 2 and 3 horsepower continuously. That is a farm power plant from a creek that most people would look at and see nothing but drainage. Harold Cook saw a power source on the Neshaminy tributary in 1918, and spent 11 years building the most efficient way to capture it. His patent expired in 1950, without ever being manufactured commercially. His 3 cardboard boxes sat in the Bucks County Historical Society for 79 years, without being opened. Gideon's wheel has been turning since 1897, with 1 rebuild and 1 set of replacement bucket sheets. The ledger beside it records 102 years of uninterrupted operation. The form that Philadelphia Electric drafted in 1932 never reached Gideon's grandfather, because Gideon's grandfather never applied for a utility connection. You cannot file an interconnection requirement against a customer who never tried to connect. The grid has been expanding its coverage and its rate base for 140 years. The stream through Gideon's property has been moving for considerably longer. The wheel turns because gravity works, and because the Amish never stopped letting it. Tell me in the comments what your monthly electric bill runs, and whether you have any moving water on your property. a stream, a creek, a drainage channel, a spring with any elevation drop at all, because the calculation between those two numbers is simpler than you think, and the distance between where you are and where Gideon is has always been smaller than the utility company needs you to believe. Hit subscribe, because next week I am going to open the third of Harold Cook's cardboard boxes, the one I have not told you about yet, the one that contains not prototypes or patent drawings, but correspondence. Letters from 1930 and 1931 and 1932, from engineers who had seen the wheel run, from manufacturers who had read Brackbell's efficiency report, and from one correspondent whose letterhead I recognized immediately and whose involvement in the suppression of Cook's patent changes the timeline of everything. That letter exists. I have photographed it. And when you see the name on the letterhead, you will understand why Harold Cook's boxes sat unopened. I will see you there.